everyone. Hope you are all fine and I hope that you could understood all the videos I have uploaded so far. If you haven't subscribed our channel, please do subscribe it. Okay. So today, like the last video, we have discussed about the refraction through the convex lens. Okay, how the image formed in a convex lens when we place the object at various locations. Okay. Today we are going to discuss about the image formation in a concave lens. Okay. So for that, first let me keep the object at infinity, okay, at an infinite distance. We know that when we place the object at an infinite distance, the rays coming will be parallel, okay. So consider this is the light ray coming from the object is at infinite distance. This is the light ray coming from the object, okay. Let us take this. So after getting here, what happens in case of concave lens? Yes, it get diverged, okay. When it comes here, it get diverged. This we all know. But when we extend this point, in the point when we extend this point, we know that all the lights will concentrate at the focus, okay. But at the other side of the lens, not in this side. In case of convex lens, we will obtain the image over here, okay. But here it will be focused in the other side of the lens, okay. So when we extend these points, we will get this image at this point, okay. So when we keep the object at an infinite distance, we will get the image at the focus, but the other side of the focus. So this is when you see this object image in the point size image. You have got a very small sized image, okay. So what is the nature of my image? What is the nature? Here, in case of concave lens, we cannot obtain the real image, okay. We can obtain only the virtual image. What is real image? Real image can be obtained in a screen. We can catch it in a screen, okay. But real, that is, in this case, that is virtual image cannot be captured over a screen, okay. Such a type of image is called as virtual image, okay. So here we have obtained the virtual image. Also, the size of the image, okay, when we compare when compared to the object, the size of the image is very small, okay. Also, when we see the image, this image will be erect, okay. So, the nature is virtual and erect image. Object okay. So, the image will be an erect image. This is in case of when the object is at an infinite distance. The next, when the object is placed anywhere on the principal axis at a finite distance. The object is the principal axis. This is the optical center. So, in the principal axis, okay, anywhere, but at a finite distance. What happens? That we can see now. So, I am placing the object in between the focus and the center of curvature. 2F means what? Center of curvature. Okay. I have placed it over here. So, let us see what happens. Okay. So, this is my object. The ray is passing through this way. One we can take it as like this. So, what happens after getting refraction? It will be diverged from this point. Okay. So, the next ray, let us take, it is passing through the optical center. What happens? It will pass through the same path, right? So, what happens? We have to find out the meeting point, right? So, where both these rays are meeting, when we extend this point, both these rays are meeting at this point, okay? So, here only the image we will be getting. Okay, so this is the image we will be getting. That is A dash B dash. So, when we place the object anywhere in the principal axis at a finite distance, we will be getting the image like this. But the location is varying. That is, it will be in between the optical center and the focus. In the principal axis, in between focus, optical center, in between, you will be getting the image. What is the nature of the image? The image will be a virtual image. Okay, in the maximum it is a virtual image. Okay, so it is a virtual image. So what is the position of my image? It is erect. Okay, the image I am getting is erect. Erect na nera irukku, talakila illa, inverta illa, nera irukku, erect image. Okay, so what is the size of my image? It is very small. The size of my image is very small. Where the image I have obtained? In between the focus and the optical center. Okay, in between the focus and the optical center. So, I have explained only one image in the last. If I place it in between that is 2f1 and f1. What is my image? Okay, now I am placing so many objects like this. Okay, இந்த இடத்துல வச்சேன்னா எனக்கு என்ன கிடைக்கும், இந்த இடத்துல வச்சேன்னா என்ன கிடைக்கும், இந்த இடத்துல வச்சேன்னா என்ன கிடைக்கும். Okay, everything we can draw it like this. Okay, here it will be like this. When it passes through the center, when this crosses, you will be getting the image over here. Similarly, when you take this, you will be getting, okay, similarly when we trace this lines, we will be getting images like this. Okay, he will be getting images like this. இந்த மாதிரி போயிட்டே இருக்கும். Okay, so this is the image you will be getting. புரியுதா? ஒண்ணே ஒண்ணு எக்ஸாம்பிளுக்கு நான் எக்ஸ்பிளைன் பண்ணேன். அதே மாதிரி வேற வேற லொகேஷன்ல வச்சீங்க அப்படினா உங்களோட இமேஜ் இந்த மாதிரி கிடைக்கும். So what is the nature? As the distance between object and lens decreases, size of the image increases. புரியுதா? அதாவது லென்ஸுக்கும் ஆப்ஜெக்ட்டுக்கும் இடையில இருக்கிற டிஸ்டன்ஸ் டிக்ரீஸ் ஆக இந்த இமேஜோட சைஸ் வந்து இன்க்ரீஸ் ஆகும். So இதோட இமேஜ் இது. ஓகே, இதோட இமேஜ் இது. So போக 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 டிஸ்டன்ஸ் வந்து அதாவது இன்க்ரீஸ் ஆக உங்களோட சைஸ் வந்து டிக்ரீஸ் ஆகும். As the distance increases, size will be decreased. Okay, that's all. Only two cases here. When it is at infinity, what happens, and when it is at placed at any point at finite distance, what happens. Okay, hope you could understood the image formation in case of concave lens. Okay, now let us discuss about the applications of concave lens. Wherever we are applying this concave lens in Galilean telescopes. Okay, in the telescopes we will be using this concave lens. Then wide angle spy hole in doors. You might have seen in the doors, right? So to find out who is on the other side of the door, we are using this lens. So when we look at through that lens, we can get a very huge, that is very big image of the that is who is standing over there. Okay, for that purpose, that is wide angle spy hole. Wide yes, door, you might have seen that. So for that purpose, we are using this concave lens. Also, to correct myopia, we are using this concave lens. Myopia means short sight. Okay, அதாவது தூரத்து பார்வை, அதாவது கிட்ட பார்வையில குறைவா இருக்கும் இல்லையா, அவங்களுக்கு we will be using this lens. For convex lens, we will be using for hypermetropia, for long sightedness people. Okay, this one to correct the myopia problem, we will be using this. Hope you could understood about the refraction through the concave lens and its applications. Thank you for watching.